Hello everyone, this is Hymavathi working as an assistant professor in the Department of Science and Humanities, MLR Institute of Technology. So in the last session, we discussed about the non-exact differential equations and the methods of finding and integrating factors. So we did the three methods of finding and integrating factors in the last previous sessions, and in this session, we are going to discuss about the method of finding and integrating factor using the method 4, and we'll do one problem on finding and integrating factor. And now we'll see what is the method 4 of finding and integrating factor. So now see the equation here. The given differential equation is a non-exact differential equations. So we know that what is a non-exact differential equation. So the non-exact differential equation is you have to verify the condition. So that condition is dou m by dou y is not equal to dou n by dou x. So this is the condition of a non-exact differential equation. So after verifying this condition, you have to find out an integrating factor. Then how can we find the integrating factor? By using the method 4 is, so you have to find out dou m by dou y minus dou n by dou x divided by n. So if this value is equal to function of x, or sometimes the constants is also exist. So you have to consider this as f of x. Then what is the integrating factor of this function is e power integral f of x dx is an integrating factor. So now let me see again. So then how can we find out the method 4 of finding an integrating factor is, you have to find out dou m by dou y minus dou n by dou x divided by capital N. So this value should be is equal to either in terms of x or constants. Then the integrating factor is e power integral f of x dx is an integrating factor. Now let me see one problem on finding an integrating factor by using this method. So now see the question. So solve 2xy dy minus of x square plus y square plus 1 into dx is equal to 0. So now verify first the given differential equation is of the form m dx plus n dy is equal to 0 or not. So you have to write the given differential equation into form of m dx plus n dy. So now let us see the solution on non-exact differential equation using the method 4 of finding an integrating factor. So now first of all you have to write the given differential equation is of the form m dx plus n dy is equal to 0. So minus of x square plus y square plus 1 into dx plus 2xy dy is equal to 0. So now this is of the form m dx plus n dy is equal to 0, right? And now write what is the function m and what is the n function. So here m is equal to minus of x square plus y square plus 1 and multiply minus x square minus y square minus 1 is the m value. And now write the n function here, n is 2xy. And now we have to verify the non-exactness condition, that is dou m by dou y. So find the derivative value of m with respect to y differentiation partially. With respect to y differentiation partially is minus 2y. Since here x square is a constant and minus 1 is a constant, those derivative values are zeros. And now we have to find out the dou n by dou x value. So with respect to x differentiation, so treating y as a constant, so by keeping y as a constant, the derivative of n with respect to x is 2y. So dou n by dou x value is 2y, and then now observe the condition here. What is the non-exactness condition? Dou m by dou y is not equal to dou n by dou x. So clearly here we got the dou m by dou y is not equal to dou n by dou x. So which is the non-exact differential equation? So now we are going to find the integrating factor. So why we are finding an integrating factor? To reduce the given non-exact differential equation to the exact differential equation, right? So see what's the method for? So the method for of finding an integrating factor is, so dou m by dou y minus dou n by dou x. So first you have to do the subtraction of those two partial derivative values. So dou m by dou y minus dou n by dou x. So what is the value of dou m by dou y minus dou n by dou x is? See the value here. So dou m by dou y is minus 2y minus dou n by dou x value is minus 2y. So write the minus 2y. So minus 2y is nothing but minus 4y. And now we have to divide with the capital N on this value. So dou m by dou y minus dou n by dou x divided by n is equal to minus 4y by, what is the capital N here? 2xy. So 2xy. So y gets cancelled here and this is also 2 times cancelled. So here we are getting minus 2 by x is the value of dou m by dou y minus dou n by dou x divided by n. So see, observe here, this value is completely in terms of x, so that you have to assume this is as f of x. And now we have to find the integrating factor. So finding an integrating factor. So what is the formula? The integrating factor is e power integral f of x dx is a formula of finding an integrating factor for dou m by dou y minus dou n by dou x divided by n. So e power integral, what is f of x we got? Minus 2 by x into dx. So here minus 2 is a constant, right before the integration, e power minus integral or minus 2 integral 1 by x into dx. So we know that the 1 by x integration is log x, right? So this can also be written as e power log x to the power minus 2. And we know the formula. So what is that formula here? So e power log x is nothing but x, right? You have to use the formula on e power log x to the power minus 2. So here the value of integrating factor is x to the power minus 2. X to the power minus 2 is nothing but 1 by x square. So this is the integrating factor we got. So you have to multiply this integrating factor to the given differential equation. So multiply integrating factor, that is 1 by x square, to the given differential equation. So what is the given differential equation we have? Minus of x square plus y square plus 1 into dx, right, plus 2xy dy. So this is the given differential equation. For this differential equation, you have to multiply with the integrating factor, that is 1 by x square. So is equal to 0. And now multiply 1 by x square with each term of this differential equation, right? So minus of x square plus y square plus 1 divided by x square into dx plus 2xy by x square into dy is equal to 0. And now here you have to do the simplification by multiplying with x square each term of the numerator of the coefficient of dx here. So minus of 1 plus y square by x square plus 1 by x square into dx plus, and here the one x was cancelled, 2y by x into dy is equal to 0. So this is the differential equation we got after multiplying an integrating factor. And now again you have to cross check whether this differential equation is a exact differential equation or not. So now you have to take, again this is of the form m1 dx plus n1 dy is equal to 0, right? And now again you have to verify the condition of exactness. So what is the exactness condition? Dou m by dou y is equal to dou n by dou x. So here what is the m1? m1 is equal to minus of 1 plus y square by x square plus 1 by x square is the m1, and now the n1 is, so here the n1 is 2y by x is the n1. And now find the derivatives, partial derivatives with respect to y on m1. So by doing with respect to y differentiation partially on m1, so here the first and the third term are the constant, so constant derivatives are zeros, and minus we have the write the minus, 1 by x square is a constant, then the derivative of y square is 2y. Right, so this derivative value is minus 2y by x square is the value of dou m1 by dou y. And now we have to find out the derivative on n1 with respect to x. Dou n1 by dou x. With respect to x differentiation here, 2y is a constant, the derivative of 1 by x is minus 1 by x square. So this can also be written as minus 2y by x square. Now once observe those two partial derivatives here. So these two partial derivatives are equal. So dou m1 by dou y is equal to dou n1 by dou x. Right. So this is now exact differential equation. Now this differential equation is exact differential equation. So now we have to find out a general solution of exact differential equation. So what is the general solution of exact differential equations? So we know that the formula is to find the general solution. Integral m1 dx plus integral n1 dy is equal to c. So this is the formula of finding a general solution of exact differential equation. So while doing integrating on m1, you have to treat y as a constant. Right? While doing on n1, you have to take which does not contain x terms. So here you have to take the terms free from x. Right? So what is the m1 function? So here what is the m1? So I am writing separately here, m1 is equal to minus of 1 plus y square by x square plus 1 by x square is m1, and n1 is equal to 2y by x. So these functions you have to write on the general formula, that is integral minus of 1 plus y square by x square plus 1 by x square into dx plus integral. So what is the n1? What is the condition we have on n1? So you have to take which does not contain x terms, right? So see observe the function here n1. So on n1 we have x term is included, so that you have to consider the n1 is 0 here. 0 dy is equal to c. And now we have to do the integration of the first term by doing with respect to x integration, treating y as a constant. So minus, and now the integration 1. Integration of 1 is with respect to x is x plus y square is a constant, then integration of 1 by x square. What is the integration of 1 by x square? The integration of 1 by x square is nothing but minus 1 by x. So here we will get the minus 1 by x. Similarly, for the third term integration is also same, that is minus 1 by x. Minus 1 by x is equal to c. So this can also be taken as minus x minus y square by x minus 1 by x is equal to c, or by taking the LCM with x, what is the equation exist here? Minus x square minus y square minus 1 divided by x is equal to c, or this can also be written as minus x square minus y square minus 1 is equal to c. So, this is the required solution of the given differential equation. So, today's session, what's the today's session we discussed? So, we discussed about the method 4 of finding an integrating factor. Method 4 of finding an integrating factor. So, what is the method 4 of finding an integrating factor? Dou m by dou y minus dou n by dou x divided by n is equal to f of x. So, integrating factor is e power integral f of x dx is an integrating factor. So, today's session we discussed about the method 4 of finding an integrating factor, and we did one problem on using the method 4. In the next session, we will discuss about the method 5 of finding an integrating factor. Thank you.